Imagine a world without GPS, without widespread internet, without reliable power. Sounds like a sci-fi dystopia, right? What if I told you the greatest threat to our interconnected world isn't a hacker, not even a nuclear weapon, but something far more powerful, something born in the heart of our own sun? Get ready to explore how space weather could literally knock us back to the Stone Age. We often think of the sun as the giver of life, our warm, shining companion that rises each morning. But behind that golden glow lies a storm no human can truly control. The sun is a raging nuclear engine, constantly churning with magnetic energy, and sometimes it erupts. When that built-up energy snaps, it hurls billions of tons of charged particles into space, a phenomenon known as a coronal mass ejection, or CME. These fiery clouds travel millions of kilometers per hour, crossing the vastness of space in just days. And if one of them is aimed directly at Earth, the consequences can be staggering. Luckily, our planet isn't defenseless. Earth's magnetic field acts like an invisible shield, deflecting much of the sun's wrath. But even shields can bend, and sometimes they break. The first time humanity truly realized the sun could fire back was in 1859. Astronomer Richard Carrington observed a brilliant solar flare, and within hours, the world's telegraph systems began to fail. Sparks flew from the wires, operators were shocked, and some systems worked without batteries, powered solely by the electromagnetic storm sweeping through Earth's atmosphere. That event, now called the Carrington Event, was powerful enough to set telegraph paper on fire. And if it happened today, it wouldn't just disrupt a few telegraphs, it could cripple our entire digital civilization. We've had smaller warnings since. In 1989, a solar storm knocked out power to 6 million people in Quebec for 9 hours. Satellites have been lost, flights rerouted, and communication links disrupted. And as our technology grows more connected and more fragile, the risks only multiply. Because in a world built on constant connection, one broken link can ripple into a global chain reaction. Think about everything that depends on space-based systems today. GPS guiding planes and ships, satellites relaying internet and TV signals, power grids balancing demand across continents, even financial systems synchronized to atomic clocks orbiting above us. Now imagine those satellites bombarded by high-energy particles, their circuits fried, their orbits shifting as atmospheric drag increases from solar storms. Imagine electric currents surging through our power lines, overloading transformers that could take months to replace. Communication networks collapse, navigation systems fail, flights are grounded, and data centers go dark. In a matter of hours, the global economy could grind to a halt. Hospitals, banking systems, emergency services, all dependent on a fragile web of electricity and signal. Suddenly, silent. So here's the question, are we ready for the next solar storm? The truth is, we're getting better, but we're far from invincible. Today, satellites like NASA's Solar Dynamics Observatory and the Parker Solar Probe keep constant watch on the sun, studying its magnetic behavior and tracking solar flares in real time. We can now predict when a storm is coming, sometimes with a few hours or even a day's notice. But space weather isn't like regular weather. Its patterns are complex, and even with advanced models, we often don't know how strong the impact will be until it's already hitting us. That's why international cooperation has become vital. Organizations like NOAA's Space Weather Prediction Center, the European Space Agency, and Japan's space agencies are sharing data, developing global alerts, and creating joint defense strategies. It's a united front against a cosmic threat that respects no borders. But detection alone isn't enough. Our infrastructure, power grids, satellites, and communication networks needs resilience built in. Backup systems, redundant circuits, and better shielding can mean the difference between a temporary blackout and a global disaster. In short, we're learning to read the storm, but we still need to learn how to withstand it. Thankfully, innovation is catching up to the challenge. Engineers are developing radiation-hardened electronics that can survive powerful solar bursts. New satellites are being designed with protective shielding and smarter shutdown modes to endure intense space radiation. And here on Earth, energy companies are experimenting with grid protection technologies that can automatically isolate or reroute power when solar currents strike. But technology alone isn't enough. We need continuous investment in space weather research and a deeper understanding of how our sun behaves. Because every new satellite we launch, every AI server we build, every self-driving car that relies on GPS adds another layer of vulnerability. And it's not just a job for scientists and engineers. Each of us has a role to play through awareness, preparedness, and supporting the efforts that keep our world connected. So the next time you check your phone's GPS or stream a video from orbiting satellites, remember this: our digital future rests on our ability to protect it from the oldest and most powerful force of all, the sun itself. Because the storms will come. The question is, will we be ready when they do? Space weather isn't just a scientific curiosity. It's a ticking cosmic time bomb. We can't stop the sun from erupting, but we can learn to prepare, to build resilience into the systems that keep our world running. Because the next great storm is not a question of if, but when. And when it comes, our survival as a connected civilization may depend on how well we've listened to the warnings written in the light of our very own star.